And hello guys, today we are going to learn how to find the prime number. Okay, for that one we can implement the logic in Java. So obviously we are all know what is prime number. Prime number means like more than one, whatever the numbers are there, those numbers only considered as prime number. But we have one logic. I mean prime number in the sense a number which is divisible by itself and which is divisible by 1, which should not having the factors. Those numbers only usually we will call as prime number. For example, let's say example 10. Okay, for 10, 10 is always divisible by itself. 10 divided by 10, obviously we'll get the 1, and it is divisible by 1. So if we are doing which is divisible by itself and it is divisible by 1, those are prime number, but we should not having any other factors. Other factor in the sense, for example, we take the 10, right? So we can take half of the number, half of the expected number. For example, half of the expected number for 10 is 5. Till 5 we need to find the factors. For example, we can take 1, we can take 2, we can take 3, 4 and 5. So within this limit, do we find any factors? Let's say 1 into 10, it will go. Obviously 1 we don't consider. You can take for the 2, 2 5s are 10. So we got the factor 2 5s are 10. We got one more factor. Let's take 3. 3 into 2, 6, 3 3s are 9, so it won't go. 4, you can take 4 into 2, 8, 4 3 are 12. No, we don't get. You can take the 5, 5 into 2, we get this. So we have the two factors for the 10. So this number is not prime number. Even always while implementing logic also, we have to implement the logic half of their number only. Whatever the number you are taking, you have to divide that number by 2, then you need to find out. So it is easy to understand, right? Even if you take 6 also, it was meaningless only. 6 2s are 12, 6 3s are 18. So it is going beyond of the 10. So we cannot consider this number as, we cannot consider more than half of their number. So always we need to take limit till half of the expected number, and we need to find the factors are there or not. For example, you can take the 13. Okay, we have the 13. Do you have any factors? 13 divided by 13, it works, and 13 divided by 1, this is normal. So these are numbers are usually called prime numbers only. Do you have any other factor? Till 13, like what is the half of the 13? Till 6 only, right? So you can take the 6. We need to find the factors to be able to find within this limit. Do we go with the 1 into 13? Yeah, obviously this we don't consider 1. 2 6 are 12. We don't get 13 in that 2 table. If you type the 3, 3 3 are 9, 3 4 are 12, but we don't get. Even 4 also we don't get, 5 also we don't get, 6 also we don't get. 6 2 are 12 only. 6 3 means 6 3 is 18, it will go. It is going beyond of that. No, we don't consider. If you take 7 means that is meaningless only. 7 means it is going beyond of our expected limit. So we don't consider till 7. We need to consider half of their limit, and we need to find the factors of that. So this is a usual process to find the prime number. So I will show you how to implement the logic for prime number. Okay, I will open the Eclipse here. So I have opened the prime program. So here actually I hope you know the basics of Java here. Okay, here if you want to give user input, we need to import the scanner class. Okay, there we can write the input in the console so that we can able to find. If not, we can directly hard code the number and we can find the number, that number is a prime number or not. For example, I will take the number called uh, I'll say the 13. Okay, I'm just, this is hard coding value, because if we go with the scanner number in the console, we can type either 12, 13, 14. Whenever you will compile, it will ask the number. Then you can enter. Then we can able to find out the number is prime or not. So now I will show you by hard coding this value. Let's say user has given 30 number. Then they need to find out whatever the input they have given. This is prime or not. They need to find. Okay, so for that we need to implement logic, right? As I said in the notepad, we have written this, right? We need to verify till half of the number. For example, we took the 13. What is the half of their number? 6 only. We cannot go for 7. 7 2s are 12. 7 2s are 14, it will go. So we don't take 7 also. We need to take till 6 only. So what is the logic for that? Yeah. So in order to iterate over the number, we have to take one for loop actually. Okay. So what I will do? I will take I equal to 2. Why I am taking I equal to 2? This is initialization part. I am directly taking I equal to 2 because we should not consider as 1. I is normal one. It is comes under the natural number. We cannot consider I is prime number. So I take the I equal to 2. I mean which we are iterating our loop from 2 only, initialization. Then whatever the number you are entering, I is less than of n by 2. n whatever the number it is there, right? This number you are entering, right? This number to be divided by 2, because as I said we need to check the limit till half of the number only. We should not go till 13, 1 2 3 4 5 6 7 8 9 10. We should not go, we need to check till 6 only. So n by 2, if it is satisfied whatever the number you are entering, which if it is satisfied, then it will get into the loop. Then I am incrementing, like for each condition incremented. So I will write I will write one loop. Okay, so whenever this code is not getting into loop, every time we need to increment the number, right? For example, we need to find till one, I mean 2, 3, 4, 5, 6, till 6 we need to check. First we will check with the 2, and if not it is not satisfied, then I will be incremented to 3. If that is not satisfied, again we will check for the 4. Again it is not satisfied, if we will go with the 5, and we will go with the 6. If completely it is not satisfied, then we'll call as it is not a prime number. I'll write the condition here. First, this is for iteration. For loop, generally I have written this is for iteration purpose. Then I am writing the logic. We need to check with the I number. When for each iteration I need to check. For first iteration it was 2 only. For second iteration I need to check 3. For third iteration I need to check for 4. For fifth iteration, sixth iteration I need to check. So whatever the number we are entering, that is mod of 2, which is equal to 0. Here I'm creating one boolean actually. Okay, boolean, I'm taking the variable called flag and true. Okay, so here if the number, whatever the number you are entering, for example you have entered number I equal to 2, I is less than of n by 2. What is the n by 13 by 2 means 6 only. Condition got satisfied, then get into loop. Then here it will check whatever the number, what is the number of n? 13. 13 mod of 2, which is equal to, is that equal to 0? No, which is not equal to 0. Again iterate the condition. I again mean, which means it is not satisfied, which is not getting into loop. Again it will go to the condition. Okay, then I will increment it to 3. There it will check the condition. I is less than of n by 2 or not. Okay, what is the n? 13. 13 divided by 2 is 6 only, right? Then here it was 3. Okay, condition got satisfied. Again it comes into loop. Here you can see n mod of I we need to give, not 2, sorry. I means like each time I value is getting changed, right? First time we have verified with the 2 initialized value. For second iteration it go with the 3. Then again it will check the mod of value. Okay, 13 mod of 3. What is the value of that? 3 3s are 9, 3 4s are 12 only. So mod means we are getting the remainder. So it is also not equal to 0. If that is not like that, it will go for complete iteration. If that is completely not equal to 0, it won't go into loop. If it is going into loop, then that is not called prime number. If condition getting satisfied for this if condition, that is not prime number. If complete it is not satisfied, then it will come out of the loop, then it will go to true condition. Then whatever we are giving here, it will print the like number, this whatever the number we have entered, that is prime number. Let's say here what I will do, flag equal to false. If the condition is getting satisfied with whatever number you are entering, if condition is getting satisfied, it is get into loop, then it will return the false. Okay, I will explain you exactly so that you will understand. So if flag entered number is prime number, what is the entered number here? N only, right? So I'm printing that. Else obviously it is not the prime number. Let me run. So now I have given 13, right? 13 is the prime number we are all know, so it should have come to this if condition. See, enter number is prime number. Let's say now I will change to 10. See, entered number is not prime number. Why 10 is not prime number? Here can you see, first we are checking the iteration of 2. Okay, n divided by 2. Okay, however we are getting the 5. Okay, I is less than a 5, so it is getting into loop. Here can you see, I value is 2, right? Number we have entered 10. Okay, 10 mod of 2, which is equal to 0. Here can you see, 2, you can take 2 divided by 5. I mean 10 divided by 2. 2 5s are 10. Then remainder what we are getting, 0 only. So which is equal to 0. So condition is getting satisfied. This condition is getting satisfied. Then code will get into loop. I mean into this loop it will enter into that, cursor will get into that. Then what is the flag value here? False. False means it will completely skip this. I mean if anything is getting if the condition is not satisfying means it will skip the first iteration. So it will skip this if condition, directly it will come to the else condition. Else what we have, like enter number is not prime number, likewise it will check. So always we need to remember, like whatever the number you are entering, we always we need to compare with half of the number. We need to compare the half of the number means always we have to give like initialized value only, because every time for each iteration it is incrementing their value. So it will count for 1 2 3 4 5 6 whatever number. If we are entering for 50 means it will check till 25. If you are entering 100 means it will check till 50. So within that half of limit only we will find the factors, right? So that's the reason we are checking with the like incremented value of initialized value. I mean this is incrementing initialized value, we are comparing here whatever the number you are entering. So likewise we can able to find the prime number. Yeah, if you like this video, please subscribe to my channel. Thank you.